This panorama shows diverse geological textures on Mount Sharp. Scientists have been investigating the mountain for evidence about changes in Martian environmental conditions from an ancient time when conditions were favorable for microbial life to the much drier present. We can see that gravel and sand ripples fill the foreground, and the outcrops in the midfield are of two types: dust-covered, smooth bedrock that forms the base of the mountain, and sandstone ridges that shed boulders as they erode. The rounded buttes in the distance contain sulfate minerals, perhaps indicating a change in the availability of water when they formed. Some of the layering patterns on higher levels of Mount Sharp in the background are tilted at different angles than others, evidence of complicated relationships still to be deciphered. Curiosity Mars rover captured this dusty wind gust blowing overhead on Mars. Scientists believe it's a wind gust rather than a dust devil, since it doesn't appear to have the trademark vorticity or twisting of a dust devil. In this amazing panorama of lower Mount Sharp, we can see that in the foreground, multiple sandstone beds show systematic inclination to the south, suggesting progressive build-out of the sediments toward Mount Sharp. At this location, about a mile north of the base of Mount Sharp, these inclined beds can be traced up to about 100 yards or meters in the direction of build-out. These inclined beds are interpreted as small deltas building out into a shallow lake. As sediment-laden river water encountered a standing body of water, the river current was forced to abruptly decelerate, leading to rapid deposition of sediment at the river mouth. This deposition led to formation of a delta. Continued supply of sediment by rivers flowing from the crater rim led to deltas building out into the lake towards the south. This image in the southern hemisphere region of Mars displays an unusual class of hybrid dune-like sandy landforms or bedforms. They display a consistent shape and tone but range several orders of magnitude in size or spacing. The smallest examples here are less than 10 meters in spacing, while larger ones are separated by several hundreds of meters. This is unusual variability for bedforms that evolve over long time scales and consistent climate of recent Mars. A Mars geomorphologist might classify some of these as small dunes or giant ripples depending on their perspective. This small, relatively fresh crater is Orion crater. The crater's diameter is about 90 feet, and from the small amount of erosion or filling that Orion crater has experienced, its age is estimated at no more than 10 million years. The sloping buttes and layered outcrops seen here are located within the Murray Buttes region on Lower Mount Sharp. The buttes and mesas rising above the surface are eroded remnants of ancient sandstone that originated when winds deposited sand after Lower Mount Sharp had formed. The layering within the sandstone is called cross-bedding and indicates that the sandstone was deposited by wind as migrating sand dunes. This view of the downwind face of Namib Dune on Mars covers 360 degrees, including a portion of Mount Sharp on the horizon. The site is part of the dark sand Bagnol Dunes field along the northwestern flank of Mount Sharp. Images taken from orbit indicate that dunes in the Bagnol field move as much as about 3 feet per Earth year. This downwind face of the dune rises at an inclination of about 28 degrees to a height of about 16 feet above the base. Curiosity Mars rover used electric lights at night to illuminate this view of Martian sand grains on the ground at Namib Dune. The view covers an area roughly 1.1 inches by 0.8 inch. This panorama shows Wdoyak Ridge with the rover's tracks visible at right. The ridge stands prominently on the western rim of Endeavour crater about 200 yards or meters west of the rim's main crest line. The ridge rises steeply about 40 feet from the base to the top and it extends about 500 feet in length. For scale, the distance between the rover's parallel wheel tracks is about 3.3 feet. Curiosity Mars rover took this panorama while atop Mount Mercau, a rock formation that offered a view into Gale crater below. This set of images compares rocks at two different parts of Mars. On the left is a rock in Endurance crater in Meridiani Planum. On the right are the rocks in Yellowknife Bay in Gale crater. The rock on the left is formed from sulfate-rich sandstone. Scientists think the particles were in part formed and cemented in the presence of water. They also think the concretions, which are the spherical bumps distributed across rock face, were formed in the presence of water. The Meridiani rocks record an ancient aqueous environment that likely was not habitable due to the extremely high acidity of the water, the very limited chemical gradients that would have restricted energy available, and the extreme salinity that would have impeded microbial metabolism if microorganisms had ever been present. In the shape bed image on the right, these very fine-grained sediments represent the record of an ancient habitable environment. The shape bed sediments were likely deposited underwater. Scientists think the water cemented the sediments and also formed the concretions. The rock was then fractured and filled with sulfate minerals when water flowed through subsurface fracture networks, which are the white lines running through rock. Data from several instruments on Curiosity rover all support these interpretations. They indicate a habitable environment characterized by neutral pH, chemical gradients that would have created energy from microbes, and a distinctly low salinity which would have helped metabolism if microorganisms had ever been present. This panorama, featuring several of the long, steep slopes of Jezero Crater's river delta, was taken by the Perseverance rover. The delta formed billions of years ago from sediment that an ancient river carried to the mouth of the lake that once existed in the crater. The image was taken from a distance of about 1.2 miles. Mars Reconnaissance Orbiter spotted this south polar formation that resembles the planter's Mr. Peanut mascot when seen from orbit. The south polar residual cap is constantly changing as carbon dioxide sublimates from steep slopes, a process that can create all sorts of intriguing shapes like this. It might take a little imagination, but you can see the legs, arms, body, and even the Mr. Peanut top hat. This clip shows Phobos, the larger of the two moons of Mars, passing overhead shortly after sunset. Phobos first appears near the lower center of the view and moves toward the top of the view. The apparent ring about halfway between the center of the frames and the edges is an artifact of the imaging due to scattering of light inside the camera.